This is Dr. Butler and this is AP Chemistry. We today are going to be doing an example from the book. We're going to do practice exercise 1 on page 682. I wrote this out already. And this is the question. A 0.50 solution of an acid, HA, has a pH of 2.24. What is its Ka value? So the first thing I am going to do is write the expression for the equilibrium expression for this acid, which is HA equilibrium equation goes to H plus A minus. The equilibrium expression is what we need to get is H plus times A minus over HA. Okay. That is our equilibrium expression. We do know, what the molarity of the solution is, and we know what the pH is. The molarity of the solution is telling us that our initial concentration of HA in this equation is, not at equilibrium, is 0.50 molar. That's what that says. The pH, which is 2.24, tells us the concentration of H plus. So we need to calculate the concentration of H plus by taking 10 to the negative pH. Remember that pH equals the negative log of the concentration of H plus. We can put this number in here and calculate that to figure out our H plus concentration, which is 10 raised to the negative 2.24, which is 0.0575 molar. Okay. Now, by stoichiometry, every HA breaks up into H plus A minus. So there's going to be the same concentration of A minus as there is H plus, which is this. It looks like we have everything. We have our H plus, our A minus, and our HA. The only thing is this is the initial concentration of HA. And so we do need to do an ice table of these just to double check on whether this value of 0.50 is going to be sufficient. So we do our initial, our change, and our equilibrium. This is our ice table. So what we know is that 0.50 molar is our initial of that. We have nothing in the products. At equilibrium, we know our H plus, and we know our A minus. We had to add X to the H plus and the A minus, and X therefore has to be 0.00575. So what 0 plus what gives us 0.00575? Well, it's 0.00575, of course. In our HA, we subtract X, so it is 0.50 minus 0.00575 gives us a 0.494 molar is our solution at equilibrium. All right, so now what we need to do is get a new piece of paper so we can do the equilibrium expression. Our equilibrium expression is Ka equals the concentration of H plus A minus over the concentration of HA. At equilibrium, we know all of these values, so all we have to do is plug them in. Our H plus is 0.00575. Our A minus is 0.00575. Our HA is 0.494. And then we calculate those numbers to get our final answer. 0.00575 squared divided by 0.494 gives us 6.69 times 10 to the negative 5. And that's your final answer, using an ice table on a weak